Good morning, participants. I am Dr. Yahila Devi from the Department of Instrumentation and Control Engineering, College of Engineering. Welcome you all for the webinar on basics of and offshore production. About our college, it is accredited by NAC with A plus and holding a NARF ranking of 160/1071 applied institution. The college has been started in the year 1994. Since now, it is running successfully with 10 units and 6 periods. Successfully. Our department is ND accredited. The main advantage of our department is that around 50% of our graduates are doctorates. We are very equipped with modern laboratories. About the speaker, our speaker is Mr. M.A.Hameed. He is an alumni of our department. He had completed production diploma in the basics of ships and offshore production from NG and Polytechnic Singapore. He also had an MBA in oil and gas from the University of Petroleum and Energy Studies, Dehradun, India. He had published many research papers on marine exhaust gas scrubbers and ballast water treatment. He had patents on exhaust gas scrubber design US and Europe and frequency-based regional control non-chemical use only. He has worked in many organizations like Capel Offshore and Marine, Royal Caribbean Cruise, Siemens, Disney, etc. for about 10 years. He is also the CEO and founder of M.A.Hameed Engineering and Identity Geek India. Currently, he is working as a Senior Vice President, Cymatic Solution USA. I welcome you, sir. I hope this session will be useful and engaging. Now, I hand over the session to Mr. M.A.Hameed. Thank you, sir.
Yeah. So can I start presentation?
No, sir, you can proceed, sir.
Okay. Is the first slide visible? Basics of ships and offshore production.
Yes, sir, it's visible, sir.
Okay, madam. Thank you, madam. Thanks for the introduction and a very good morning to all the participants. Am I audible?
Sir, you're audible, but now your screen is not visible in the YouTube live stream, sir.
Yeah, please check. Is it? I'm on the first slide. Is the slide visible now?
No, sir, it's not visible, sir.
Okay. Let me share. Can you see my first slide now?
No, no, sir, no. We are not able to see your screen, sir.
I have shared it now. Can you see now?
No, sir.
Should I cut and connect again? Hello.
Hello.
Can you see the screen now? I have already shared it.
Yes, sir. No, sir. Sir, we are not able to view your screen, sir. Yes, sir. Now it's visible, sir.
Is it okay now?
It's okay, sir. Now.
So, basics of ships and offshore production. A brief process overview. That's the presentation topic for today. The scope of the presentation, what we're going to see today is we'll see why FPSOs are used in offshore production, some data and projects of FPSO, types of production systems, what are the different types they use in offshore production, what is the factor that is favoring the use of offshore production. In offshore production, there are a lot of modules, so we will see a few modules that are used in offshore production. We will see the modules and their functions as well. And I'll give you a interpretation of the process flow diagrams and we can move for questions. If I run a little faster, just correct me to slow down so I can slow down. So this is pretty much the scope of the presentation for today. And okay, asking everybody a question. About 2/3 of the surface of the Earth is covered by water. So it's actually about close to 71%. So we have remaining of close to 29% of land area.
Excuse me, sir.
So we have refineries, oil exploration, drilling of oil.
Excuse me, sir.
Yes.
So, sir, there's some bandwidth problem, I think so. So, can you please turn off your camera and then present it?
Yes, sir.
Because the camera also tries to take some bandwidth. So, try to turn off the camera and then go for the slideshow, sir.
Okay. I've turned off the camera. Is the slide visible now?
Now we have some clear audio. A slide is available.
Okay. Is the slides visible? Okay.
Yes, sir.
Okay. Can I proceed now?
I can proceed, sir. Thank you for your cooperation.
Yeah. Yeah. So about 2/3 of the surface of the Earth is covered by water. So the remaining 29% is the land area, which we are talking about exploration in Saudi Arabia, in Kuwait, in Iran, Iraq, and all the African nations, and in US, and in India, and Russia, and all these places. But we have 71% of water, that is sea, and in below that sea, the seabed, there is millions of gallons of oil and gas and fossil fuel there. So we're talking about close to 70% of area which is unexplored. But the cost of drilling, cost of producing oil from these areas are going to be expensive. It is not going to be a walk on the cake, like cakewalk, like on the surface of the Earth. It is easier, whereas in the sea you have a lot of uncertainties. You need a lot of more technology and safety concerns and all that. So, but we have a lot of demand for this fossil fuel. So we also, and we have to find out if there is oil in oceans, below the oceans. So the exploration started like decades before, and they found out that there is a lot of oil below the Earth. So we're talking about 2 times more than what is on the land, is like 30% more than 4 times more than what is available on land on sea surfaces. So that is what is offshore production. Okay, why do we have to use an FPSO? So basically, ships is used for transporting logistics purpose of oil and gas and cargo, heavy cargo, bulk cargo. When you say when you transport car, vehicles, it's called logistics, and then you transport crude oil from one country to another. Okay, one of the world's largest refining capacity. Based on refining capacity, the largest refinery in the world is present in India, in Gujarat. So for that refinery in Gujarat, which is the largest refining capacity refinery, the crude oil has to be transported from Iran or in Saudi Arabia to India. So the crude oil, which is the base raw material, India or from Iran to India via sea. So when you transport such large quantity of crude oil from countries where it is drilled to a refining country like India, you use a vessel called VLCC, very large crude carrying vessel. VLCC it is called. When you use a smaller vessel, feeding vessel, it is called a tanker oil or crude oil tanker vessel. So these kind of vessels are used, ships. When you say vessel or ship, it is the same. So you use those vessels to bring oil from those countries to India. So we have a requirement where we have to now produce or drill and produce oil in the middle of the ocean, out of nowhere, somewhere on the earth, where we have to just drill and get the oil. So when we had a requirement like that, the industry experts met and said to build a ship like that, it would be very expensive. Rather than building a new ship, what we planned was to take a existing ship, which is 10 years old or 20 years old, and retrofit it with a floating production, storage, and offloading capacity modules. So we took it is like making a normal Indian Jeep or a Mahindra Jeep car and making it to a more offloading or technically retrofitting a normal car into a more sophisticated car, or taking a Hero Honda bike and retrofitting it with all the other bullet extra fittings and making it a better. Took a 20-year-old ship, VLCC, very large crude carrying vessel, and converted into an FPSO. So the definition of FPSO is it is a vessel, it is a ship which can process and store oil. So on the vessel top, there will be a lot of modules which is very similar to what you will find in a refinery, in land-based refinery in Gujarat or in SR Oil or any other company in the world. So you'll have a feed of crude oil. When you dig like normally when you put a bore well in your house, you get water out of it. But when you drill a rig, like you drill into the earth's surface, like say 4,000 meters or less, you say 1,500 meters, when you drill and you get production, you will get crude oil, you will also get water, you will also get gas. These three things in combination will come out of the well. So when you receive all these three, you will have to process it. So it is very difficult to process everything inside in the middle of the ocean. So very basic processing of separating the oil, gas, and the water is done on the site itself in the middle of the ocean, and we move that to the refinery for further consumable products. So FPSO definition as such is a processing and storage of oil and gas, receiving oil, processing it, and storing it inside it. So that is an FPSO. It is very, why do we use an FPSO? It is very easy to install this FPSO. So if there is a drilling done in a Mexico or Gulf of Mexico or in North Sea or in Gulf of Mexico, wherever it is, you have to just transport this FPSO ship to that location and just connect it to the Christmas tree. So then you will start production. So after like maybe 5 years of production, you can disconnect or dismantle it and move it to the next location. Yeah. Okay. Real-time example. So these are the ships which are really producing oil and gas in the ocean. So you can take down the name and you can Google it for open source information about these vessels. Just names of ships. And BW vessel's name. BW Offshore is the company's name. FPSO Captain the vessel's name, and FDM is the company's name. Okay. When it comes to drilling and production, there is a difference. Drilling is exploration. When you want to find out if this particular area has oil or gas, it is called drilling. When you want to produce, like you already found out that there is oil there in that particular location, and then you have to start producing, then it is called production. So there is a difference between drilling and production. So drilling is done by drill ships. The production is done by FPSOs. So you have to differentiate between drilling vessels and FPSOs. So FPSOs are not drilling vessels but production vessels. After we have found out there is oil and gas in particular well, we move the FPSO to that location and we start producing. Whereas drilling is used done using drill ships and semi-submersible drilling vessels, which will just find out there is oil here using seismic studies, and then drill to the well and find out there is oil, cap it, and move on. So there is a difference between drilling and production. That is to be known. Next is how they drill it. Okay, now we have found out in Indian Ocean there is a particular GPS location where the seismic study has confirmed there is oil and gas. In a well, there will be oil, gas, and water, all mixed together in ratios. If the oil ratio is very high and the gas and water ratio is low, it is called an oil well. If the gas ratio is high and oil is low and water is also low, it is called a gas well. If only water content is high and oil and gas is very low, it is just a normal water well, and that will not be considered for exploration or production of oil. It is not feasible to spend so much money to take that little oil and gas and waste so much on water. So they will not explore that well. They will not use production of that well. Okay, so basically it is two wells, oil well or a gas well. So how they are named: if oil is more, it is oil well. If gas is more, it is a gas well. But most of the wells will have a combination of oil and gas. Okay, in that well, after deciding, okay, now this is going to be an oil well, we have 95% of oil, 3% of gas, and 2% of water. So total of 100%. In that, the 95% of oil is our capability to produce it. The 3% of gas is another product, but on the oil well, we have to go prepared for a oil production. In order to just eradicate those 3%, you will flare that 3% in the site itself. Flare is just burning it out on the surface of the ship. So above the surface, in 15 meters height, you just flare that extra gas you get from every barrel. So you flare it, and whatever water which comes with the crude oil is processed on the surface of the ship and re-injected back into the well. Why do we have to re-inject the water that you already spent so much money and extracted from the well, and you inject it back into the well through the sides of the well? In order to you do that to maintain the well pressure. So basically there is a cup of water, and in top of that cup of water there is oil. Now you're putting a drill bit there and production line, and you're pumping oil out of it. When that level of oil is moved out, you'll start pumping water, or you'll start pumping air out of it. There's no oil coming further. So in order to make that oil always meet the production line, you'll have to inject water to the bottom of the well, so that because of the density, getting a call. Hello. So because of the density of water and oil, the oil will always come on the top, and the well pressure is maintained by injecting the water. So that is how the drilling and well operations are maintained. So drilling as such, it is done using a drilling ship in which the derrick, blowout preventer, turntable, and engine turntable and mud casings are used, and a complete well casing is done using cement structure. After this drilling is completed, the casing
Excuse me? Excuse me, sir?
Yeah.
Sir, if you are changing slide, we are not able to have a changed slide, sir. We have only that for second slide available.
Can you see
that
now?
Is about 2/3 of surface is that slide is alone all available.
How do I do that? Can you see now?
No, sir, it's a blank screen. Now it is available. Drilling and production. That slide is available.
I'll change slide. Can you just check if it's changing? Is it changing now?
It's changing now.
Changing now?
It is changing.
Okay. So this is the about 2/3 of surface of water. This is the slide. And then I was talking about the definition of FPSO. This slide. Then we have examples of FPSO. So you can take down the names of these FPSOs and Google it for more information. The next slide is drilling and production. The difference between drilling and production, this is what I was talking about. Then we have to find out how it is done. So how is the drilling and casing is done? So using a drill ship or a semi-submersible drill ship or a normal drill ship, you do a drilling and you case the drilling site with the mud and cement casing. This is normal unidirectional drilling, but nowadays we also use horizontal drilling and directional drilling. So if it is unidirectional drilling, like suppose say how you have a borewell in every house, everybody has to do a borewell individually in everybody's house. But when you have a neighbor and he drills 500 feet and he does not get water, but whereas in your house you drill only 100 feet and you get water. So the neighbor, he is just 20-30 feet away from your borewell, is trying for 500 feet and he doesn't get water. So what he can do is he can do a directional drilling from his house towards your borewell to the well from which you are getting water. So he can drill through his house floor, but he can turn his direction after 20 feet and like diagonally move towards your house well, and he can pump water. So similarly in drilling, the difference is you save a lot of money if you do directional drilling, because you don't have to do unidirectional, lot of wells to pump oil from the same well or nearby wells. Okay, well completion. Okay, when you have found out through seismic studies and other geographical studies that there is oil in this particular part of the world, then you move a drill ship or a semi-submersible drill vessel and drill a hole and find out, okay, there is oil here. This is good for production. So after that is ready for production, you decide to plug or complete the well. Plug is just plug the well and move the vessel out of it and start producing after 5-10 years. Now I don't have money to produce, so after 5-10 years I'll produce. Otherwise, you decide, okay, now I have found out there is oil here, I'll immediately start production. So if you're not producing immediately, you plug the well. If you're producing immediately, you complete the well. But how do you complete the well? You remove the blowout preventer. Blowout preventer is a kind of non-return valve which sits on the top of every well before production. So if you decided to produce oil from that well, you remove the non-return valve. The blowout preventer is removed. You fit a Christmas tree. It is just a valve manifold, a big manifold with lot of valves, so that whatever oil produced, or crude oil, gas, and water, whatever comes out of the well, is directed through many pipelines manifold. That is called the Christmas tree. Then you lower the production tubing from the FPSO towards the Christmas tree. Then set plug of the perforations inside the well casing and you blast the holes in the production interval. When you blast a hole, automatically through well pressure, the hydrocarbons or whatever production material will automatically get to the surface of the vessel. To maintain the well pressure, as I already mentioned, we have to inject water or gas according to the availability in that particular location. So that is how a well is completed. Okay, we have different types of production systems in the shipping in offshore. This is basically decided on the environmental condition. If it is shallow water, only 100-meter depth, then you decide to go with a jack-up rig. The jack-up rig is a rig which has 3 legs, which jacks up on the surface of the earth and then starts producing. Then you go to tension leg platforms, which are platforms which float on the water, and then a mooring line is fixed to the surface of the earth, sea, and then you start production. Then you have steel jacket production platforms. Then you have surface tree, semi-submersible production platforms, deep draft semi-submersible platforms, and ship-shape FPSO. So we are concentrating on ship-shape FPSO. But in the picture you see, these are the different types of offshore production units that are used commonly. This is how do you decide, okay, which is the one is based on the depth of the seabed. If the water surface to seabed is 100 meters to 150 meters or 200 meters, you use up to 300 meters, you can use jacket bricks. Beyond that, you use tension leg platforms up to 700, 800 meters of below water level. And then above 1000, you start using drill ships, FPSOs, or semi-submersibles up to 3000 meters. So very deep sea drilling is mostly favored or done by semi-submersibles, and semi-submersibles are the biggest capacity of offshore production vessels platforms. So that is the different types of production systems used in offshore, and we are concentrating for today's topic into FPSO alone. Okay, what are the factors? Why do we have to use FPSOs? The location of the field size, operating water depth, mobility of the FPSO, and decommissioning and reuse. The usage of FPSO is very, very good because you can use the FPSO in one location for 5 years and then decommission it and move it to a new location and for the next 5 years. An FPSO has a lifetime of 25 to 30 years or beyond. If it is well maintained, we can go up to 30, 40 years as well. So the technology keeps changing. So companies like Bechtel are companies which give process systems for oil production. They keep changing the technology. Okay, I earlier mentioned that India has the highest yield or highest refining capacity refinery in the world today. The reason why India has the highest refining capacity is the yield, the production yield out of 1 barrel of yield is about close to 98%. So if 1 barrel crude oil is given to the Gujarat refinery, 98% of that can be converted into consumable products. Only 2% of it is not used or cannot be used as a product. Whereas refineries set in Saudi, Iran, Kuwait, or even in US were all set up using technologies which are earlier, like 10 years earlier or 15 years earlier technologies. So their yielding capacity or production like ready goods capacity is only up to close to 85 to 90%. So that is the main reason why India has the newest technology, which because it is recently set up in the last 10 years, and that is why India's refinery is the highest yielding capacity refinery in the world as of today. We see Reliance, we see SR, a lot of other companies, Indian Oil and all that, but worldwide, the company which gives technology resource or technology operating solutions to these companies is one monopoly called Bechtel. So Bechtel is a company which gives process solutions on refining technology to the world, entire world. So this is one monopoly company which decides how oil is produced. Factors favoring FPS. Okay, and another two major factors which we think is favorable for using an FPSO is the first choice for new areas where there is little or no existing infrastructure, because there need not be any infrastructure available nearby. The FPSO can just sail out to the ocean and stand anywhere on the GPS location and start producing oil and gas. So that is a major advantage of using an FPSO. And for example, you see this FDFPSO, as you write, is the name of it. The location is Murphy West Africa Limited, the company, and it's in West Africa. The capacity is 60,000 barrels of oil per day, and it is also producing 18,000 MSFC cubic feet of gas as well. So you have such high capacity per day, and this is just can start doing it in a single day. Like today, the ship can sail, anchor it, and start production from tomorrow morning. So that is how quickly an FPSO can start production. So that is the advantage of using an FPSO. The field size and marginal fields, even for small fields where only the capacity is only for 2 years or 3 years, you can still use FPSOs because it can be decommissioned and moved to a new location very easily. So FPSOs are favorable for all reasons. Water depths. When it comes to water depths and high, like very bad and weather, North Sea, for example, is very cold. There's a lot of uncertainty in weather all the time in the year. Floating production systems are shallow water depths. They used it for shallow water depths there because the conditions are very, very uncertain. Environmental conditions are very uncertain. So they started using jackup rigs. Instead of jackup rigs, they started using FPSOs. So as exploration and production have moved over increasing water depths, now production from bottom founded structures is no longer viable, and the range of floating systems must be deployed. So there's a lot of new exploration and new areas where FPSOs are used. Very fast. 8 knots is like 4 kilometers, 16 kilometers per hour. So you have a, like from this part of the world to the next part in 15 days, you can move to the other part of the world. So FPSO can sail to new locations faster. It can disconnect. It can be decommissioned very fast. It can work on all weather conditions, very bad weather conditions. It doesn't matter. It is a ship, so it can sail and stay there, anchor, and start production immediately. So these are the benefits of using an FPSO. At the end of the field, FPSO is decommissioned. Like after 10 years, the well is empty. There is no more production capability. It can be immediately decommissioned in a few days' time and moved out to a new location. The advantages of FPSO in a summary. So the economic benefits of utilizing upgrading floating facilities. So it is not a new ship which is built from cutting the metal. It is an existing ship which is already 20-25 years old. We take that ship and convert it into an FPSO. So it is like buying an old car or a bike and changing into a refinery, floating refinery. So it becomes economically beneficial. In many cases, the remote areas where other vessels cannot go, this FPSO can go there and start drilling. Even for small fields, only 1 year or 2 years of production, installing other vessels is difficult, but you can move a FPSO and start production. The water depth is not an issue, climate is not an issue, small periods of production, small capacity wells is not an issue. So there's a lot of advantages of using an FPSO. Okay, how is a vessel converted into an FPSO? Okay, this is the basic structure of a FPSO. So as I earlier mentioned, it is normally an existing vessel or a ship which is converted into an FPSO. So you have a ship which is 20-25 years old. You take that ship, take out all the top modules, clean it off like a normal football field, and then you plant every module, like one module by one module. The higher structures, two higher structures, hope you all can follow my mouse. This is a turret and this is a flare. This is an extra gas which comes, it will be burnt. This is a flare stand and this is a turret. So this is an internal turret. There are ships, FPSOs, which have an external turret, like a how you have a basketball beam, cantilever beam. So like that, in some ships, this turret is positioned outside the hull in this area, but most of the cases it is done like this. As an engineer, I prefer ships which have an external turret because it is easy to have these mooring lines, these incoming pipelines to be visible all the time on the upper side of above the water level. In this ships, in this FPSOs, all this mooring line and anchoring lines are below water line all the time, and you have a lot of difficulties in maintaining the pipelines, production lines. So I prefer, as an engineer, I prefer having external turret in vessels, but this is built with an internal turret. So these are mooring lines or production lines, and these are anchoring mooring lines, which is like fixed anchors into the surface of the sea. What happens here is a similar situation like as you have a pencil and a compass and you draw a circle. This is an anchor point. These are mooring lines anchored to the seabed. So this ship will take a 360-degree rotation irrespective of any climatic condition. So any wind or anything, this will be anchored to this position here using these mooring lines, and this ship will always rotate all 360 degrees without disturbing any production. So once the crude oil with gas and water enters through these production lines to this turret, the main job of the turret is to rotate and give this production modules oil, gas, and water separately. So this separates in a high pressure. It spins like a separator, oil water separator, and it gives oil, water, and crude oil and gas and water to the modules. First module is module number 1, high pressure separation. So from the turret, the production yield crude oil, gas, and water. So then the 3 goes to the module 2. This is the low pressure separation. So from high pressure separation, you go to a low pressure separation. Then from low pressure separation of oil, water, and gas, the production goes to the 3rd module where you have gas dehydration. So whatever gas in an oil field, whatever gas you have is taken out from the oil and water, and then that is flared. So you can go to the 22 flare stack, and then whatever excess gas is there is flared. In some ships, if the gas is a good amount, they will use that for operation of the ship, producing electricity using a gas generator, so or some other production for the ship's operational fuel of an operational purpose. The gas is used. Otherwise, the gas is flared completely in the flare stack. Then gas lift compressors. So these compressors on module 4 are for use for gas lifting, and then in module 5 the gas lift process is even further compressed, and then you go to module 18, which is a lay down area. It's usually for equipment lay down, and then in module 15 you can see PS lay down area again. So these are the orange modules are the main functionals of the production, initial production of crude oil. So the production comes to the turret, it goes to the separators. Basically you use oil water separators, and then on the top the gas goes up. So the gas goes to a compressor, and then gas is flared. The oil water separator, usually Alfa Laval is the company which produce oil water separators. So you can Google Alfa Laval for oil water separator and how they function. All that can be found. So oil water separator just spins. It's kind of a centrifugal and kind of setup. Then you have compartment based or compressor. There are different technology based on the density of oil, what kind of crude oil. Crude oil is kind of a recipe. Like you have different kinds of food. Like same biryani can be made in different names, right? So similarly, crude oil in different locations is found in different recipes. So you take a sample and find out what is the kind of separator I need. You have to tell Alfa Laval, okay, this is my yield, this is how I am going to separate it. Then they will manufacture, is all as built, like to a spec. So this is basically the conversion of a ship into an FPSO using these modules. The other modules are further modules which are using for water injection, sulfate bed, utility, laboratory, and all the other operational categories, which are not part of actually the oil thing. We will further see the modules separately as well. So I'll go to the next slide. So oil separation is done in module 1 and module 2. So here you have 120,000 barrels of oil per day that is done in first and second module. Gas compression and treatment system is done in 4, 6 and module 7. So 118 mmsfd of gas is produced in 4, 6, and 7. Water treatment systems is in module 9 and 10. We have 90,000 of BWPD of oil water that is treated for re-injection into the well. Utility and power generation, that is almost 6 modules, and Alstom is the one monopoly which produces power generation systems for FPSOs. Most of the companies which are associated with FPSOs equipment supplies are monopolies. There is no competition there. Because they're age-old companies which have learned a lot of things and they have patented it, it is very difficult for a new company to come and compete. So Alfa Laval is for separators, Alstom is for power generation, Wärtsilä is for automation. If instrumentation engineers, if you want to pursue a career in automation, you should look into this company called Wärtsilä. Wärtsilä is engine manufacturer, the monopoly in MAN BMW and Wärtsilä are two companies like Alfa Laval, ABB. Most of the instruments are George Fisher Instruments or ABB. These are the two companies which provide instruments. You will on the land-based refineries, you will find a lot of other companies competing, because to get an approval for a product in the land-based refinery, you have a lot of companies which compete and they easily get an approval. For a for an equipment to get approved by IMO, International Maritime Organization, and to be installed on a ship surface on a floating rig is a big process. So it is very difficult to get into that market. So they usually have only 1 or 2 companies which do. FPSO Falcon is an example of conversion. Normal ship is converted into an FPSO. This works for ExxonMobil. That is the company. Process equipments. Okay, in a FPSO, what are the process equipments that you use? On the turret, you have a FPSO mooring system. Turret is where the entry of production oil comes into it, and it is called a turret. In this ship, you can see an external turret, which I was earlier mentioning. This has an external turret. The advantage of having an external turret is always the pipelines are visible and the mooring lines are visible. And this is, to an operational perspective, as an engineer, I prefer this, and this is better. Top sides, the top of the ship is called a top side, and the top sides have modules. As I earlier mentioned, oil, gas, and water processing facilities are on the top sides. What happens in this bottom part of the vessel? In the bottom part of the vessel is where whatever produced oil is there. It is all stored in this bottom part of it. So crude oil storage, accommodation, services. When you say services, but close to 25-30 people live here on the ship, so they all have to stay here. This is the accommodation block. Here they have a kitchen, gym, a normal life after work can be here, and they also have an engine here. And then this is the engine operation from moving from one place to another. They use this, so they have an engine. We have an auxiliary generator for power, and all this is in this part of the ship. Remaining this complete part of this blue and red part is for storing capacity of, you can see close to, you can see 22 lakhs barrels of oil is stored here. Crude oil is stored. This is not petrol or diesel. It is just crude oil without water and gas is stored in this storage capacity. So turret, to look into a turret, this is an external turret. I like external turret. And sometimes they also call this as risers. Serve as mooring system to which anchor lines are attached. All the anchor lines are attached to this, and this is also production lines. This allows the vessel to freely weather wind. Like it can take a 360 degree like a compass, and it can move around due to weather, wave or wind or any environmental conditions. So this is a turret which we already saw that. So turrets. So again, this is an external turret which is outside the ship hull. This is an internal turret which is inside the ship's hull itself. So these are just to say that external and internal. Swivel. So this is actually a part of the turret. the conveys incoming fluid pass through the swivel first to the fixed part and then to the rotating part of the turret and to the topside processing facilities. So it is just a high conveys incoming fluid. It comes in a high pressure, so it rotates and separates in different pressure levels to rotating part of the turret and to the topside facilities, where we can separate using high pressure separator and low pressure separator. We will separate oil, gas, and water. Okay. Functions of topside processing equipments. So oil comes through these lines to the turret, and from here it moves to the module 1, where oil, gas, and water is separated. Then it goes to high pressure separator, to the low pressure separator, where you have again oil, gas, and water separated, and further goes into the storing capacity. After all the storage oil is in this part of the ship, then a tanker ship comes, which you can see a small ship here behind is actually a big ship. It looks smaller here on the picture. So on like 2 days once or 3 days, depends on the capacity. This production, whatever is produced and stored in this FPSO, is transported to this tanker, oil tanker. So this takes the production to the nearest refinery, maybe Reliance or wherever the location. If it is in Africa or Saudi or Iran, wherever, it moves it to the nearest location. So topside has been fabricated with a number of modules. So all these are modules. So you can see a heavy lift here. You can Asian Hercules. This is a floating heavy lift crane. This is only available in Singapore. This is Asian Hercules is owned by Keppel, my ex-company. They rent this crane across the world. This lifts the complete module. This is called a heavy lift process. You have all safety to be done, and then this complete module, for example, say module 1 is completely lifted and placed on the FPSO. So this is manufactured in a shipyard by module. Module 1 is manufactured, then this is lifted and placed into the ship. Then module 2 is manufactured, then lifted and placed into these ships. Okay. So how many modules? There are close to 16 modules on an FPSO topside. How much does a module weigh? It weighs about 75 to 710 tons each, depending on what process it does. The modules weigh between 75 to 710 tons. Module 1, HP and IP separator. So I already talked about it. High pressure separator and low pressure separator. So these are the two separators in module 1. Then in module 1, the separators, how does it work? Okay, here when you have inlet, you have oil with water and gas come inside. Water with the density goes below, and then you have oil which floats on the top, and then you have gas here. So this is how a separator works. You also have a different diagram here which says a little bit colorful picture of liquid retention, water out, oil out, and gas out. So basically what separator does is separates oil, water, and gas. So this is a horizontal 3-phase separator. You have different technology according to the requirements of the site. If the crude has different qualities, you use different type of separators. This is a horizontal 3-phase separator, high pressure. Then you have a low pressure separator in module 2, where the produced products of module 1 comes into this, and then module 2, same thing is done, but using low pressure, because you have already pretty much separated water, gas, and oil. Now you want to further refine it, further remove the small water droplets in oil, further remove oils in water, and remove gas. So that you use a low pressure separator, and then after the produced oil is moved to the cargo tanks. So all over the bottom there is cargo tanks, which is used for storing the produce from module 1 and 2. The high pressure gas compressors. So when it is a gas field, or you want to use the gas for your oil power production in the ship, you use module 4, where gases from mod 1 and 2 are gone to the mod 4 processor gas compressors, and when you have to maintain the well pressure, to sustain the well pressure, you will re-inject the gas into the reservoir itself. But in some cases, if you don't, you inject only water and you flare the gases. Module 7 is for flash gas compressors. So this is, you use screw compressors in the module to use the flash the gas to whatever requirements. Low pressure gas, which is being separated from crude oil in mod 2 and separator in mod 1, is compressed to a pressure where it can join the produced gas and the HP separator at the inlet of the main gas compressors. So this is basically like when you want to flare the gas or use the gas, it depends according to the situation and requirement. This is done in a flash gas compressor. You have screw compressors. So this is another type of compressor where high pressure gas from the main gas compressors must be further processed to remove water. So to further remove the water from that, you inject it into a screw compressor, which removes all water particles from the gas. This drying is achieved by model 6, where glycol is used to absorb the water. So there are different chemicals according to the requirement. In this particular site, glycol is used. Whereas in another site where the gas composition is a little different, the water to get absorbed might use glycol plus certain other chemicals can also be required to absorb the water. Okay, then basically when you have such kind of a refinery offloading, offshore refinery, you will need a lot of heating and cooling utilities for pressure and to maintain the pressure lines, the steam lines and all that. And you all know that crude oil needs a certain temperature to like move. It at a normal room temperature, it will be like frozen. So it has to be heated. So all the pipelines which are used for transporting crude oils from the production lines to the storage lines, it is all heating lines. All the pipelines will have a heating coil on it and then insulated, so that users can touch the pipe, nothing will happen, but then the pipes are always heated, so that movement of pumping and all that is achievable. Gas turbine generator, because we need a lot of power to do all this process. So we have GE and ABB. These are the two companies which give, Alstom is another company, but GE, ABB also does that. We have, GE has a gas turbine which can run on crude oil. Siemens has a gas turbine, SGT 500. SGT 500 is the only gas turbine in the world which can run on crude oil as a fuel. We also have gas turbine research going in India for last 25 years, and the name of the gas turbine is Kaveri. So this has been like India couldn't fund the project after 20 years. Now actually France is funding the project. I work on a working group on that, and then that project has been put on hold for a long time. So that is also a gas turbine which can work, is the lightest gas turbine which India is manufacturing, working on in ISRO in Bangalore. So this is something related to gas turbines. So when that gas turbine comes into application, you'll be using such gas turbine. But as of now, in the market, you have Siemens SGT 500, which is the only gas turbine in the world which can run on crude oil as a fuel. So you need a lot of power, so you need a gas turbine to manufacture power. These are local equipment rooms for purpose, like you have to have a power distribution to all switch gears located inside the equipment rooms. You need a lot of air conditioning and all that is there. So you use a local equipment room as module. Water treatment. You have to inject the water into the reservoir. You cannot, whatever water which comes out from the well with the oil has a little percentage of oil and mud and all that. So when you re-inject whatever you get on the surface of the ship back into the well, there is a regulation which says that you have to treat the water and inject permissible amount of certain things to the reservoir. So you treat, this is a water treatment system similar to a reverse osmosis process, but it's a technically a little different. It's similar to that. Water treatment is done to remove oil using centrifugal force, and then again you do it a few more times, and then you inject it. Turbidity and PAH, para aromatic hydrocarbons. So these are the two terms which is regulated. Like you should have certain amount of turbidity and certain amount of PAH, polyaromatic hydrocarbons. So these are two things which are measured in the water before it is re-injected into the well. Gas turbine generators we have already seen. Chemical injection. So you need to inject chemicals into the gas turbine and other places wherever there is a process requirement. Basically on separators as well, you need chemicals to absorb water like glycol. So you have a chemical injection plant, which is module 14. Module 16 is chemical injection again, the flare gas scrubbers and pigging pumps. So you need to do pigging on a regular basis to clean the pump, pipelines, pipe spools. Then you have to flare gas to avoid any safety issues and all that. So this is module 16 where you can see the flat tower and the modules. You need methanol injection. Okay, gas hydrate is a completely different process. Methane hydrate, sometimes they call it methane hydrate or sometimes they call it gas hydrate. This is kind of a complete chemistry kind of a thing where methanol storage and related to pumping equipment, test separator and a storage dispenser are in this module. This is more of a R&D kind of a system where you test the, like on a daily basis, you take the little amount of crude oil and test the quality of it and tell, okay, this is what is the amount of crude oil, water and these chemicals are coming out. So you decide on the production, okay, this is how our yield is going to be. So this is kind of an R&D setup module, methanol injection module. Okay. So this, again, going back to the module 1, this is how the primary production system works. This so when well fluid comes, it goes to a high pressure separator, gas goes to a compressor, oil goes to a low pressure separator, water goes to water treatment. So low pressure separator sends the whatever gas comes here, sends it back to the compressor and gas dehydrator and pump it to gas to pipeline. But if this is very less of quantity, this directly goes to the flaring and it is flared. Water treatment, water is after the treatment, water is discharged or re-injected into the well based on the requirement. Oil, after removing the further gas, is separated the water as well. It goes to the storage, which is below the FPSO. So this is oil dehydration using chemicals and then oil liquid pipeline or to the tanker to refinery. You will have to see a complete setup of the modules as well. So I'll show you this. Can you see the construction module? Harisha, can you see the construction module? Can you see the construction module? Hello?
Hello?
Can you see the construction module slide?
No, sir. No, sir.
Which side do you see, ma'am?
Sir, the screen is plain, sir, now.
Okay, ma'am, I'm sharing it again.
Okay, sir.
Can you see now, ma'am?
Yes, sir. Yes, sir. Now you can.
Construction. Okay.
Construction
So
module
now,
1, sir.
yeah. So now we will see how a module is constructed in a shipyard. So this is module 1. So we are going to see only one module. So I will go through the complete process of how a module is manufactured in a shipyard. So this is an FPSO. And this is having a complete modules on the top. So first what happens is you will have steel plates, steel cutting it is called. So you will use automated robots to cut the steel as per your drawings. and then next step is you will have a lot of raw material, a lot of steel plates like this coming into the yard. You will have automated robotic lifting of steel plates. These are all 10 steel plates, and Nippon Steel is a major manufacturer of these steel plates from Japan, Nippon Steel. And so materials come into the yard. They are lifted using automated lifting systems. Then they are also cut according to the drawings using automated robots. Then you have prefabrication in progress. So how you use automatic robots, and you also use welding labor to cut and build a prefabrication process of modules, frames. Each frame is built, and then you have further fabrication of each frame, and you have each section frame aligned, and then support of each section frame is provided. For the welding, you see this process of producing a module takes, for a team of 100 to 150 members, to take 1 year, close to 1 year, for a manufacturing of one complete module. Most of the equipments which are installed in these modules are not shelf, like they're not manufactured and kept in the company like ABB or any company you call it. They don't manufacture and keep it. They only start manufacturing it after we place an order. So in order to keep the cost low. If it is produced and kept on the shelf, the product cost goes up. So in order to reduce cost, they produce it only on order. Hence, the lead time for this is 6 months, and the module production time is close to a year. So you can see every frame is getting ready. All channels are getting ready. You can see the assembly of pancake in process. We call it a pancake. When a structure is getting ready, you call these structures as pancake, because you keep one on top of another like a pancake. So you see the assembly of pancake in process. This is another. So every pancake process, you have a frame structure, and then you keep a top, and then you keep another. This is almost like 6 to 7 feet in height. So that is like a floor. So every pancake is completed with a proof. Then you have installation of secondary and tertiary beams, and then you connect the channels. Then you connect the beams, and then you put together superstructure. That is the superstructure. Fit up the assembly of superstructure. So the superstructure is coming up. So the complete installation of superstructure is in progress. These are different views of the superstructure from different angles I'm giving you. So once the complete structure is ready, before you even do anything, you cover it completely using a plastic, and you do a blasting and painting of all these structure. So you completely cover it. In blasting itself, there is various type of blasting. You use mud, you use various other type of things according to the customer requirements and the environment. It is, if this chef PSO is going to be deep sea or any other water condition, it is going to Europe, is it going to Asia, according to the environmental conditions of that sea, the blasting differs, the blasting technology differs. And then painting also, the customer spec will be there that I have to use paints without certain chemicals like asbestos. The paint has a little percentage of asbestos. Certain companies or customers will come and tell us that you should use a paint which does not have any percentage of asbestos. So we have to find, there's a lot of research, ongoing research on the sites when the production happens, according to the customer requirements and field requirements. So when the blasting and painting is completed, the module looks like this. Then you start the fabrication of pipe spools. Every piece of pipe is called a spool, pipe spool. So everything is pre-engineered using softwares. So you will exactly know what is the diameter, what is the strength, what is the welding, and all the spools. Some are rubber coated, some are insulated, heated lines, and all that. All instructions come to the yard. So piping engineers get on the job and do pipe spools. When the pipes are ready, they get installed here. After the pipes are installed, then we go for the equipments, electrical and instrumentation and piping commence. So when you do piping, you will be installing flow meters. Then you have whatever measurement devices like valves, control valves, then pressure gauges, temperature gauges. Then you have mostly the variables that you monitor on these lines are pressure and temperature and flow. Uh, in water lines, you will be monitoring PAH, polyaromatic hydrocarbons, turbidity, and you will be monitoring PAH and pH sometimes. These are the variables which you will be monitoring. Atmospheric temperature at all places will be monitored. So after the ENI and piping commence, you will be seeing more of insulation of piping. This is how the piping is insulated, insulation piping. Then insulation work overall, and these are the equipments. So you will see the separators. So when the equipments come, you install them, and then you can see them painted later. Then the fabrication of ENI works in progress. So you keep the cable trays. You run all the cables through cable trays, cable ladders. Then you can see here the heating coils on the surface of the pipes, and then they're all tied up. This is the picture before insulating the pipes. So all these pipes with heater lines will be insulated. I'll show pictures of it later. So you can see this is how the module looks, almost ready for lift. You can see the insulation. So before we saw pictures of these separators without insulation. Now you can see them insulated. You can see here it's insulated. This is also insulated. Some are insulated like this. Some are insulated with metal aluminum sheets on its outside. This is another complete picture. So this is pretty much done, and it is ready for lift. So the Asian Hercules comes. The heavy lift day is a big day for all engineers in working on this. Close to 100 to 150 engineers work on each module, and we 20-30 people work on each module. So it takes about close to an year to get this module ready, up and ready for lift. So here you can see module Q1 loadout, and Asian Hercules is lifting it. So you can use this heavy lift on 24th April 2011. This was lifted. So this is the complete module being lifted now. So this module is lifted and then placed on this vessel. So this is how every module is built and placed on the top side of a FPSO. So by that, we come to the end of our presentation. Hope I've been okay with the understanding, and hope you all had an overview of what an FPSO and oil production is in the offshore production industry. Now, probably, ma'am, sir, we can go for questions if there is any. Hello.
Hello.
Yeah, ma'am, I'm done for the presentation.
So I think the session was very informative, and as of now, there are no questions regarding this. So
Okay.
I can able to have a generalized question.
Yeah, sir.
Electronics and instrumentation, you said that, right? So what role we have specifically as an engineer? Instrumentation.
Um, okay, basically, how this industry works is you have to join the shipyard. The shipyard as an E&I engineer. When you join an E&I shipyard as an E&I engineer, you'll be asked to do commissioning as a junior commissioning engineer. So when the modules are getting ready, you will be given the papers, all the drawings, and you will have be asked to work with the laborers. So they will be installing all the equipments, and you have to give them the right guidelines. How to install a pressure gauge, how to install a flow meter, uh, all these things. So that is how an E&I engineer will start his job in a shipyard. After a few months, like maybe one project, maybe 1 year, then they will move him to a design stage, to an office location where he has a practical knowledge of installation. Then he will be asked to write spec sheets based on customer requirements. So customer will say that, okay, now I have a requirement for West Africa. This is my spec. This is the requirements for a module. Then the E&I engineer will have to find out suitable flow meters, suitable pressure gauges. We have to compare between Emerson flow gauges, ABB, George Fisher, so all the other suppliers. Then you have pump requirement, pump specification. So all this. So basically, an E&I engineer or an electrical engineer both have a same kind of duty. Most of the times, because electrical E&I engineers are very less in the market, electrical engineers are more. Most of the time, these jobs are taken over by electrical engineers. Very few companies will have a specific E&I or instrumentation engineer. Most companies will have an electrical engineer who will be overlooking all this work. The work is very very interesting, and every day it is challenging as well. New requirements will keep coming. You have to talk to suppliers, and you have to find out which is the suitable equipment or instrument used. So it is very challenging, and it is very good paying as well. You get good packages in these industries. But where to look for a job? You have to start to apply for jobs in shipyards. Shipyards is where these are manufactured. So you have to join a shipyard to work on these projects. Hope I've answered the question.
Yes. So since the number of instrumentation engineers are less, so we need to have a detailed study, and a career will be available for the instrumentation engineers. So I hand over the session to Dr. E. Aguilar ma'am for a vote of thanks.
Thank you, Harish sir. Now I would like to thank the speaker of the session, Mr. M.A.Hameed, for a wonderful webinar. He explained the concept of ships production and FPSO system in a very detailed and interesting manner. It was a very nice session, sir. Thank you, sir. And also, I would like to thank our beloved chairman, Dr. B. Babu Manoharan, and managing director, Ms. Jessie Priya, director, Mr. Shashi Shekhar, our principal, Dr. Vadi Sheshagiri Rao, and our dean, Dr. B. Parvadavatni ma'am, for giving this opportunity to conduct this webinar. Last but not the least, I would like to thank all the participants for participating in this webinar. Thank you all. And I would like to end the session with a quote that, stay home and stay safe. Thank you. Thank you, Harish sir. Thank you, Hamid sir. Harish.
Thank you all.
Thank
You
you.
for the participation.